So good morning dear friends. Last lecture we start this topic, that is a pH meter. So we complete this pH meter, electrodes in pH meter, that is calomel electrode, working glass, different type of calomel electrode. Second, that is glass electrode, reference electrode or actual working electrode. Working advantages of glass electrode, disadvantages. So we consider this pH meter, how we determine this EMF of glass electrode. So there are two type of pH meter, that is a potentiometric or side-wide type. Second is a direct reading type. So today we start this direct reading type of pH meter. So what is this? For direct reading type, before we measure the pH, initially we have these three arrangements. We should standardize that pH meter by using these three arrangement. What is the first arrangement? A, that is a control knob or a set buffer standard or calibrated. A glass electrode has an asymmetric potential which make it difficult to relate or measure electrode potential directly to the pH of the solution and makes it essential to calibrate the electrode. So this is the control knob in which we have this standard buffer calibration. The pH meter therefore should include a control, so that with the electrode assembly, that is a glass electrode and standard calomel electrode, placed in a buffer solution of a known pH, the scale reading of the instrument can be adjusted to the side wire value. This is desired value. See, this instrument can be adjusted to the desired value. Suppose we use the pH, we use the buffer solution having pH 4, then this value should be 4. If you use the pH buffer solution having pH 9.2, at that time the desired wire should be 9.2. That is this knob is used for standardization of instrument, and the standardization process is carried out by using standard buffer. So this is the calibration point. Second, this temperature probe. That probe temperature dependence on a glass electrode potential for a given pH value, make it necessary to include a biasing control so that the scale of meter can be adjusted corresponding to the temperature of the test solution. So temperature control knob is used for setting the temperature. Third point is the slope control knob. Slope control. See, this slope control is used to adjust the desired value. So see, this is the desired value. This desired value is adjusted. If not, the standard buffer is used. If pH meter do not show desired value, that desired value is adjusted by using this probe, that is a slope control knob. If the meter is calibrated at a certain pH, for example 4, what are the buffer? That 0.05 molar potassium hydrogen thiolate solution or buffer solution shows the pH 4. Then when the electrode assembly is placed in few buffer solution of different pH, for example 9.2 pH, which is made by using this buffer, that is 0.01 molar sodium tetraborate buffer. So these are the two pH range by using two different buffers. The meter reading may not be agree exactly with the known pH of the meter reading in the second solution with agreement with this known pH value. The meter is again checked in a first buffer solution, that is pH 4. Then it is assumed that this meter is standardized and will be given accurate reading for all pH values in the pH range between 4 to 9.2. So in this case what happened? Initially this glass electrode dip in first buffer solution, it shows pH value 4. If not, then we adjust it by using this slope control knob. We adjust this pH 4. Same glass electrode is then dip in another buffer solution showing pH 9.2. If not, then we again adjust this control knob. Again we place that same glass electrode by washing with distilled water in first buffer solution. At that time it should show the pH 4. These two solution used for standardization of instrument. For that, this same glass electrode, same electrode shows both pH. If it adjusted for both the pH, then we get this range of pH, and we standardize that electrode, that instrument for the pH scale 4 to 9.2. And then this instrument, that pH meter, is used for testing the pH of solution. What is the combination of pH electrode? This construction, see, in this construction we combine pH electrode with standard electrode, that glass electrode with, so this is the glass electrode. We combine this glass electrode with calomel electrode, and both are connected to this potentiometer. This is the test solution. What is the construction? This glass electrode is manufactured by sealing a thin pH sensitive glass tip to the end of the heavy wall glass tubing. The resulting tube is filled with a solution of HCl. Offer that solution having concentration is 0.1 molar. It is saturated with silver chloride. Silver is immersed in a source. See, what is the silver chloride? Silver chloride and silver is a internal reference electrode. This HCl we see in this glass electrode. What is the connection? A silver is immersed in the solution and is connected via a external lead wire to one terminal of the potentiometric device. The glass electrode can be coupled with the external reference electrode. External, see, this is the external electrode, that is a saturated calomel electrode. This is the external reference electrode connected to the potentiometric device, which is connected to potentiometric device. In this glass electrode we have this internal, that is silver and silver chloride as an internal electrode, internal reference electrode. So that part we completed in electrode point. The complete assembly of cell is shown in this figure. Note that this cell is connected to the two reference electrode. First is the external reference electrode, that is a calomel electrode or saturated calomel electrode, and the second one is the AgCl, that is a internal reference electrode, which is placed in this glass electrode, each with potential that is constant and depend on the pH. The internal AgCl electrode is a part of glass electrode. This is not external part, it is a part of a glass electrode, so it is called as a internal reference electrode. But it is not pH sensitive component. In fact, this thin membrane at the tip of electrode response to pH, this is the thin point is there, and which is the electrode response to a pH change, provided that the internal HCl solution is maintained at the constant concentration. So inside this bulb we have this HCl solution, that is 0.1 molar HCl solution. Outside we have this test solution having different pH concentration, and this thin membrane of the tip of glass electrode, this is the thin membrane electrode responsible to pH change. What is the pH change? It is the internal HCl solution is maintained at a constant. This pH change depends upon this internal layer and outer layer of H plus ion. Internal layer is formed by using this HCl solution, and we have this potential. We develop this EMF or potential and reading the pH. Under this condition, this potential of AgCl electrode insert into AgHCl solution will be constant. That internal solution is same, that is 0.1 molar HCl solution, and that potential is constant, and hence this potential between the HCl solution and the inner surface of the glass tube remain constant. So this potential which can be vary is that existing between the outer surface of the glass bulb. जे पोटेन्शियल बदलणार आहे ते मध्ये तर सेम आहे, HCl सोल्युशन सेम आहे, इंटरनल रेफरन्स इलेक्ट्रोड पण तोच आहे. बाहेरचं सोल्युशन बदललं तर पोटेन्शियल बदलेल, and thus this potential is varying with existing between this outer surface of the glass bulb and this solution into which it is the immerse. ग्लास बल्ब ज्या सोल्युशनमध्ये टाकलेला आहे टेस्ट सोल्युशनमध्ये त्याच्यावरती इंस्ट्रुमेंटचं पोटेन्शियल डिपेंड आहे. दिस pH potentially change by changing the outer layer of this glass bulb, outer surface of glass bulb, and which is changed by changing the test solution. And so overall potential of electrode is governed by the hydrogen ion concentration of the test solution. जे काय पोटेन्शियल बदलणार आहे ते कोणामुळे बदलेल तर टेस्ट सोल्युशनमुळे बदलेल. आणि इफ वी चेंज द टेस्ट सोल्युशन, potentially change, pH is changed. So for this test solution having various pH concentration, H plus ion concentration, it shows a different potential and we reading it as a pH value. A complete cell for pH measurement can be represented as. So this is a complete cell. बघा मित्रांनो, हा इंटरनल इलेक्ट्रोड फिक्स आहे, मधलं कॉन्सन्ट्रेशन फिक्स आहे, म्हणून मधलं पोटेन्शियल कॉन्स्टंट असणार आहे. जे काय पोटेन्शियल बदलेल इन्स्ट्रुमेंटवरती रिडिंग चेंज होईल पीएचचं, ते कोणामुळे बदलेल तर टेस्ट सोल्युशनमुळे. ही सर्व असेंब्ली इथं आपण कनेक्ट केलेली आहे. दिस AgCl, what is this? This is the internal reference electrode. This is a reference electrode, internal reference electrode, AgCl, which is connected with 0.1 molar HCl solution. So this second part is the 0.1 molar HCl solution having its H plus ion concentration. That is the inner concentration which is constant. This inner H plus ion solution, that solution is constant, and so its H plus ion is also constant. This 0.1 molar HCl solution, its H plus ion constant, so it shows constant EMF, constant potential. And that internal electrode placed in glass electrode. It is the internal electrode which is inserted in glass electrode. So this is a glass electrode, which is the working electrode. What is the test solution? That's आपल्याला pH मोजायचा, that is the test solution. This glass electrode is connected with test solution. This is the internal electrode placed in glass electrode connected with to the test solution. This internal electrode, glass electrode, is connected to the test solution which having its unknown H plus ion concentration. आपल्याला माहिती नाही what is the H plus ion concentration of that unknown or test solution. This is the test solution having its H plus ion concentration, that is unknown. This double line, what is the double line? This double line shows connection with another, that is a standard or secondary electrode, which is a calomel electrode. What is this connection? KCl, saturated KCl solution, mercury with paste of mercury and mercury chloride, that is a secondary standard electrode. So this is another external reference electrode. This is a secondary electrode and it is a external electrode, externally connected to the potentiometer. And this AgCl, which is a internal, which is already placed in glass electrode. So it is an internal reference electrode, and this calomel electrode is a reference electrode, external reference electrode. And we determine the H plus ion concentration. This H plus ion concentration is changed, unknown, which is the concentration of test solution. By changing this concentration, this EMF is changed and we get the reading, that is the pH on pH meter. This scale of pH is changed on pH meter by changing this H plus ion concentration which is present in test solution. So this is a simple working. So this is a complete assembly working of checking of pH of any test solution. Outside this test solution is connected to this external reference electrode and connected to the glass electrode with internal reference electrode. So measurement of pH. The following general procedure is used for making pH measurement with the instrument pH meter. First, the instrument is switched on for a warming up. For warming up, and then buffer solution is used to standardize the pH meter. These buffer tablets are available for supplying the pH meter, and the tablet is dissolved in a specified volume of distilled water to have a buffer solution with known pH. That tablet is used to make this buffer solution, and that buffer solution is used for standardization of pH meter. So first point is warming and standardization of pH meter. Second, if the instrument is equipped with temperature control, if instrument having this temperature control knob, at that time we set the temperature control at a test solution. Test solution चं जे temperature असेल ते temperature इथं set करायचं आहे. Third, the standard buffer solution, say for example pH4 is a small beaker and inserted the electrode assembly into the solution and set the selector switch of the instrument on a read pH. आपल्याला स्विच असा सिलेक्ट करायचं की त्याचा pH 4 आला पाहिजे. So this is a standard buffer solution. Next fourth point is adjust the set buffer control to the get the meter reading with agree with the known pH of buffer solution. जे काय बफर वापरणार आहे, we have the two borders, lower buffer pH buffer and high pH buffer, and we set the pH of instrument. Remove the electrode assembly and rinse it with distilled water. After measuring the pH of buffer, we remove the electrode assembly, rinse with distilled water and place it with a small beaker containing a second buffer solution, say pH 9.2. If meter does not agree exactly with the known pH, then this adjusts the slope control. We direct reading type, we have this 3 point, that C point, slope control. कुठपर्यंत ॲडजस्ट करायचं आहे till we get this desired value as a pH 9.2. So we have the two buffers, pH 4 lower pH and pH 9.2 higher pH, by setting this slope control knob. Then take the standard buffer solution and see, we completed this set buffer solution. Remove assembly, this point is also completed. Remove the electrode, see this, by using this slope control we till we get the desired value, we get this desired value. Next, remove the electrode assembly and wash it with distilled water and place it in the first buffer, that is pH 4. Again we wash that glass electrode with distilled water and we place that electrode in previous buffer, pH 4 असलेला बफर मध्ये प्लेस करायचा and confirm this meter shows, pH meter shows same reading as this pH 4. If not, again we adjust that slope control to calibrate the procedure. See, same electrode shows pH 4 for pH 4 buffer, 9.2 pH for the same, this 9.2 pH for the second buffer, and then this calibrated electrode, calibrated instrument is used for checking the pH of test solution. See, after calibration, rinse the electrode again with distilled water to remove this external H plus ion concentration and place this electrode assembly in a beaker containing a test solution. Read the pH of the solution on pH meter. So first we standardize instrument by using buffer solution, and then by washing that electrode with distilled water, that electrode immerse in test solution and we directly read the pH of test solution on pH meter. Remove the electrode, rinse with distilled water and leave them standing in distilled water. आपलं काम संपल्यानंतर, after experiment is completed, we place that glass electrode in a distilled water for placing. Next point is a standard buffer, a reference for pH measurement. So that point we already complete in our CH103, that is first semester practical course. We complete this part. So in theory book, what they gives the procedure for making the different type of buffers, that is preparation of some aqueous standard buffer solution. So that part we completed in practical session in semester first. In practical book we have this detailed procedure. We make different solutions of buffer, we determine its pH by using pH meter. In addition, we have this experiment, that is to check the capacity of buffer. That part is also included in our practical, same practical which is included in semester first. So that part we already completed in practical session. Next point is the application of pH measurement using pH meter. What is application? See, this accuracy of pH measurement not only depends on this external factor, that is temperature, pressure, flow. It depends on calibrated pH electrode. See, that calibration part is very important. Not only external factor, this calibration is very important. But also on each electrode need to be matched to a specific instrument with buffer solution. So that electrode calibration, which is very important and which should be matches with instrument. Same pH should be displayed by that instrument. If the instrument has an accuracy, suppose that instrument has accuracy of plus minus 0.01 pH unit. The instrument 0.01 plus minus pH unit साठी बनवलेला असेल and the buffers are specified at plus minus 0.01 pH unit, and therefore this electrode has an accuracy of plus minus 0.01 pH unit. सी जर आपलं इन्स्ट्रुमेंट ह्या ॲक्युरेसीचा असेल 0.0 प्लस मायनस pHचं, देन आवर दिस इलेक्ट्रोड इज ऑल्सो हॅविंग द ॲक्युरेसी ऑफ प्लस मायनस 0.01 pH unit. So this pH measurement is not only depends upon this external factor, temperature, pressure, but it also depends on pre-calibrated pH electrode and also on the specified instrument. That is very important. So what is the application of pH meter? It is used to measure the pH of biological fluids such as blood, urine, etc. It is also used to know the pH of buffer solution, we already know. Third, to maintain the pH of reaction condition. So this reaction condition we check by pH meter. Useful in determining the concentration of solution by pH measurement. So we determine the concentration of solution. To measure the pH of soil. Soil pH is determined by using pH meter. We measure the pH of rainwater or rainfall pH. The rainwater pH is measured. It is also maintained. The pH level help in several daily activity. So daily activity we use different chemicals. So we check its pH and we maintain the pH by using pH meter. These pH meters are employed chemical, paper and pulp, pharmaceutical, biotechnological, logi and petrochemical industries. So these are the different industries in which we measure the pH meter. We use the pH meter. This pH meter help in analyzing the exact pH value of chemical substances and food grade products, ensuring high level of safety and quality. See, this is very important point. This food grade products, whatever may be the available ready for material, packed material, that pH value should be checked for our safety and quality purpose. So at that time also this pH meter is very helpful. So these are the different applications of pH meter. So thank you dear friends. So in this way we complete our last chapter, that is 5th chapter, pH meter. Thank you very much.